Hello, this is question 3 of the extended response section, and we meet Manny the fruit grower who something, oranges is medium, continuous random variable. Anyway, we want to find the probability that a randomly selected medium orange has a diameter greater than 7 centimeters. Well, we can assume that that's from 6 to 8 centimeters there, and that's our probability density function. So we're looking at the integral from 7 to 8 of f of x, our function, dx. That will give us the probability of selecting an orange with a diameter greater than 7 centimeters. So it's likely that this function is going to pop up again, so we may as well define it. Menu 1.1, define f of x. Don't worry if you have previous definitions of f of x, this will override that definition. So we have 3/4 times x minus 6 squared times 8 minus x. Okay, that's done. Now we want to integrate from 7 to 8, and that should give us our probability. F of x dx, 11 on 16, there we are. So the probability that a randomly selected medium orange is greater than 7 centimeters is 11 on 16. Okay, then Manny randomly selects 3 medium oranges, and we want the probability that exactly one of them has a diameter greater than 7 centimeters. So it should jump out at you that this is a binomial problem. The reason is we have a definition of success and we have a bunch of trials. So let's look at that in terms of a binomial distribution. We know x is binomial because we're sampling 3 oranges and we're looking at the probability that exactly one is greater than 7 centimeters. Well, we know from the previous part that that probability is 11 on 16. Now we want to find the probability that exactly one of the oranges has a diameter greater than 7 centimeters. Exactly one. And this is where we use our binomial formula. You'll notice that it wants a fraction. Now, if you use the Cas functions to get the answer, I'm pretty sure it forces you to have a decimal answer. So you need to know the formula here. The formula is NCR times the probability of success to the power of R times the probability of failure to the power of n minus R. Right, we can sub in our numbers. The number of trials is 3, and we're choosing one orange as our successful one that's greater than 7 centimeters, and the probability of that occurring is 11 on 16. That's to the power of 1. Probability of failure is 5 on 16 squared. Okay, we can work that out now. So 3 choose 1 is just 3 times 11 on 16 11 on 16 times 5 on 16 squared. 5 on 16 squared. 825 on 4096. 825 on 4096. And they're both positive integers. So you can see what we've done there. We're sampling 3 oranges. and we're successful if it has a diameter greater than 11 on 16. So that implies it's binomial, and then we're defining this random variable x, and we're saying the probability that x is equal to 1 is given by this formula, which you should all know. Plug and chug those numbers in, and there's your answer. Rightio, now we need to find the mean diameter of medium oranges in centimeters. They've called them medium oranges just to confuse you. Find the mean diameter of medium oranges. Well, that formula is the integral from 6 to 8 x times f of x dx. So that formula is on your formula sheet. I can just jump up here and we can chuck an x right there and change that to a 6. That should give us our mean, 36 on 5. So the mean diameter is 36 on 5 centimeters, which is just above 7 centimeters. And that's our answer there.